Hey guys, how you doing? It's Coach Scott here with Purple Wave Chemistry. All right, so let's look at these today. Uh, this is our Unit 9 Worksheet 3 Molar Concentration, and this is a very important concept. What it is something we as chemists use to measure how much stuff is in how much liquid, how much solution. All right, we call it molarity. You might have heard percent by weight, percent by volume. All right. You might have heard proof. Like 80 proof is 40% alcohol. All right. That's a way of measuring concentration. Percent by mass. That's a way of, or by weight. That's a way of doing concentration. We as chemists like to use molarity. All right. Which is a measure of moles per liter of solution. Because we've talked about moles for a long time now, and you can see that they're sort of important to us. Let's look at question one. So if we dissolve sodium chloride in enough water to produce a 1.5 molar, see the capital M solution, what does this tell us about how much sodium chloride is in there? Well, sodium chloride is, let's see, it's about 23 grams plus 23 plus 35.5, about 78.3, 23 plus 35.5, about 58.5 grams. Well, 1 mole is 58.5 times 1.5. That means I've got 87.75 grams of sodium chloride in that solution. That means I have 1.5 moles in that liter of solution. That means I have 1.5 times 6.02 times 10 to the 23rd formula units of sodium chloride in that solution. That means I have 1.5 times 6.02 times 10 to the 23rd sodium ions in that solution. You see where I'm going with that, right? So we can use that ratio a lot of ways. Let's look at one of these problems though. So I've already calculated the molar mass of this potassium nitrate. All right, and let's see. I've got a 45.3 gram sample of KNO3, all right, potassium nitrate. And it's dissolved in enough water to make 225 milliliters of solution. All right, so KNO3, I already did it. I looked it up before I recorded this. Is 101.097 grams per mole. So let's do that. Gotta get my pen there. There we go. So I got 45.3 grams of KNO3. Let's convert that to moles. 1 mole is 101.097. I looked on the cheat sheet down below. 97 grams. Calculated on my calculator. 45.3 divided by 101.097. I got 0.448 moles. All right. 0.448 moles of KNO3. So I'd like to know how many moles are in this solution, right? Or what's the molarity of this solution? What's the concentration? So if I take that number of moles and divide it by the number of liters in my solution, let's go ahead and convert that over to liters, 0.225. All I gotta do is switch that pesky little decimal over 3 places to the left. See what I get. Divided by 0.225 means I got 1.99 moles per liter. Molarity of 1.99 moles per liter. Capital M, molar. 1.99 molar. Molar, a lot of people says that different ways. It all works for me. All right, so that tells me how many moles are in a liter of that solution. So it gives me a standard, if you would. Let's look at this on number 4. An alcoholic iodine solution, iodine, tincture of iodine, is prepared by dissolving 5.15 grams of iodine crystals. And let's see, iodine is I2, all right? Have no fear of ice, so I2. So that has a molar mass of, let's go write this down, it's pretty big, 5.15 grams, all right, times 1 mole, little cheat sheet, is 253.089. 253.809 grams. So what's our molarity? Our molars? Our moles? I get it right. 5.15 divided by 258.809. I got 0.0199. 0.0199 moles. Okay, so again, to get the molarity, that's what it's asking for. I divide the moles by the liters of solution. So let's convert that milliliters over to liters, 0.225 liters. And do our calculation. So that means I got a 0.0884 molar solution. 0.0884 molar, capital M, molar solution. That lets me know what the concentration is. That means I've got that many moles per liter of solution. I've got a nice little standard there, right? So that's good, right? So there you're going to draw what are they called? Particle diagrams. That's good for you. Let's look at number 9 real quick. We can do that one. It's not that hard and very relevant. So concentrated hydrochloric acid is made by pumping hydrogen chloride gas into distilled water. So if concentrated HCl contains 439 grams of HCl per liter, see that, 439 grams. All right, let's see how many moles that is. 1 mole of HCl is 36.5 grams. Let's see what the molarity is, or moles are. 439 about 36.5. I get 12.02, or 12 moles. Alright, and it's in per liter of solution. 12, it says 1 liter, so that means moles, that is I'm going to write that down as 12 molar solution. 12 molar of HCl per liter of solution. That means I've got a bunch of hydrogen chloride in that solution. If you recall, we used 6 molar hydrochloric acid, which is half of that. That'd be what, 219 grams of hydrogen chloride per liter. Still, this is pretty concentrated. This is the type that will burn you, alright? So you want to be careful around it. So guys, that's how we do molarity. Hopefully this helps. If you have any questions about another one of those, email me or text me and I'll make another video tomorrow. And I want you guys to understand this a little bit, and because I think it's helpful for you. So guys, this is Coach Scott saying have a great day, and hullabaloo, connect.